Sorry if this is weird. I'm listening to you, I promise, but this has a microphone in it. Amazing, right? Um, so unit testing is part of test-driven development. What are some specifics about unit testing that we're all familiar with, that we've used it for? Yep. Test our models. Sam, what's the pattern that we've used to set up our tests? Yep. We've used this Xcode test framework that has this function that we've used over and over and over to say, let's assert that something that we've created is matching what our expectations are. This word assert is important. Why do we say assert? What is, like, conceptually why we are asserting it? There's a pattern that we've used to set up all of our unit tests. Sunny, I think you mentioned it yesterday. Yep. What is a range? What is to arrange? Michelle, what is this act? How would you describe this act step of a unit test? So that's this step right here, the assert step. We can kind of think of arrange as the pre-work that's going to start to set up our test. Act is right before we actually make the test, when we actually assert it. So what would you do during an act step of your unit test? Yep. We'll actually apply what's actually being tested. And assert is saying, did this meet our expectation? Nope. Meet. Did this meet our expectation? Great. So every time you've written a unit test, for the most part, it's been to test our models, right? That's because this word unit is very intentional. Someone describe to me what you think a unit is. Shout it out. Sorry? A chunk of something. Cool. Ayula, you have a look on your face like you've got a thought. You have a look on your face like you have a thought. Express the thought. Ah, man. Damn. Okay. Anyone else? Could be a unit of data. So the reason this is called the unit testing and it has this specific purpose is because when we refer to a unit is some self-contained code that you have created. So think about your code in terms of working on the team, because ultimately that's a big reason why we're writing unit tests. If you're working on a team and you create a model and no one else knows what that model does, but you include a test saying this is how this thing should decode, this is how this thing should operate, this is how we should be able to use it, that is a unit test that explains what your code is for. So there are like many ways that we communicate in a team of developers. Sorry, Sam. There are many ways that we, without even sending a Slack message, communicate in a team of developers, right? We have Git commit messages. We might have documentation. We also have our unit tests to say, I created this and this is what it does. So this is both a means of communication and it's not just writing a message. What is testing actually doing? Like informally. What's the point of a test? Catch bugs. More broadly, pass fail, see if it does what it needs to do, see if it works. See if code does what it's supposed to. So the reason up to this point that we have literally just tested our models to make sure they decode is because most of our models don't do anything. Most of our models just get information, hold it, and then we send it somewhere, right? Whether it's into a view controller, whether it's to make a post request, all of that stuff is not actually functionality of our models. That's functionality somewhere else in the app. So for example, outside of the realm of unit tests, we have other kinds of tests. The first example we might discuss is how do I actually get information off the internet? And the reason this is not a unit test is because you didn't create the internet. You didn't create the way that your apps receive information off the internet. You likely did not create the actual computer or server that's sending you information off the internet. So this is a test for how you are integrating with other people's technologies. This is called an integration test. This is you putting your parts in with someone else's parts. This is you trying to plug in something else into your code. Unit test is testing your code and communicating that you've done your job. An integration test requires two parties or requires you to figure out how something else works in someone else's code. So that's why, beyond the fact that it's asynchronous and annoying, an integration test is not the same thing as a unit test. So making a GET request to get some JSON involves more than just your unit test that would have decoded that JSON. It involves the internet working correctly. It involves the person who created that server working, creating it correctly and communicating that information in the specified way, the way you expect it. So an integration test is you fitting your code in with someone else's code. And that's why that is very different than a unit test. The unit test is purely, again, your work. What about if we were to get info into a view controller? Would you say we are testing UI? We could. What would you say we are testing? Because I don't think this is a unit test either. Actually, I gave away the answer, sorry. So getting information into our view controller and making sure that it operates correctly, that is a UI test. That is saying that the user interface works in a specific way. It might feel like it should be similar to a unit test, but again, we didn't create UIKit. And UIKit's sole purpose is to show us stuff. Using some underlying data. So we might have unit tested our model, but then getting it into the actual user interface we would need a UI test. How do we feel so far? Let's just look at our notes here. Cool. A couple other things. Before you learned how to code, what would you say testing an app was? Have you ever tested out an app? Have you ever made sure things work? Does anyone know what that process is called? So a beta process is an example of a specific type of testing as well. Has anyone ever made a phone call, or like I in college, been on the delivering side of a phone call where you tell someone this call will be monitored for something? What is that something? Quality control, quality assurance. So QA, which is quality assurance, is kind of an abstraction from these other kinds of tests where we test that, hey, this thing works like it's supposed to when someone non-technical is using it. When you make a phone call, you have an expectation that whoever is talking to you on the other line talks in a certain way. If you're calling me circa 2009 in College Park, Maryland, and if you're using an app, you expect that the app works in the correct way. All these things so far are not unit tests because all these things so far are not you communicating and double checking the code that you have written that exists as an independent unit. These are separate. You could feel free to try to create them, but they are not unit tests. Phoenix. That's a great question. The first step is they want unit testing. So if you're doing test-driven development, which we haven't even really talked about the process today yet, right? But test-driven development, when we demoed it the first time, is actually writing the test first and then creating the model, creating the unit, creating the behavior behind that unit. We create the test first in an attempt to predict how our code should work. We say, if I have a model that's a museum, which we will do in just a second, if I have a model that's a museum, the museum should look like this. It should decode into this, or the museum should do this. And so when they talk about test-driven development, it's not even that you need to be super proficient in any of these. It's actually a pattern of thinking that they're looking for. It's a good question. Cool. Sunny? Yes. So they would follow arranging, which there'd probably be a bunch more arranging with an integration test, for example, if you're getting stuff off the internet. Then they'd involve acting. So if we're getting stuff off the internet, we would probably need to set up what we expect it to match, and also set up maybe like for an asynchronous call, we might set up like a timeout, for example, because part of that test might be, we expect the information to get here in a certain amount of time. And then to assert it is the same thing. It's, we expect this to happen. Did it happen? Could be XCT assert. Could be what we're going to look at today called quick, which is like a fancified version of XCT assert based on how other languages do unit tests. It's just much more intuitive, more so than anything else. Language works better, it's nice, I like it. There's one more kind of testing that, for example, if you were creating, I don't know, a game, you had to keep track of like, I don't know, the game state. Are you all together? You're there, you're there, you're there, and then you're there. Okay, great. So just for example, if I was creating a game And that game had various steps, right? If I was playing tic-tac-toe, and I want to make sure that when someone puts down an O, the next person's turn is the X. And if they put down an X, the next person's turn is an O, and so on and so on. And then I want to check the game state and see if anyone won. This is called a behavior test. This is where we're testing out how the actual functionality and the quote unquote business logic of how the thing works is actually working. So in a behavior test, for example, with tic-tac-toe, you would have a test for each move in a potential game. And then to actually bring this full circle, you would also test scenarios that have edge cases. So if your game's not working right, and this is also true of unit tests, if your code is not working the expected way, you should write an additional unit test for it. So coming back here, we test our models, that's great. There should also be a test, if you remember our JSON serialization mini lesson. Say our models received inconsistent data from the JSON that they got off the internet. There was one case where we had a heterogeneous value that could be either an int or a string. I would want to make a test saying this model is set up for a heterogeneous value. Now you could set up a separate JSON that you want to test that just has maybe an example where it got a string for that value and an int for that value. You might test the same exact data as before, but you want to have a test in there saying, here's something particular that you should know about my model that I wrote. Because again, your unit test is a means of communicating what your work does. So this kind of falls under the aegis, I love that word, of bugs. When you notice a bug with your work, write a test for it so that other people know where it can go wrong. I'm going to say that again because that's super important for what we are all doing right now. For your units of work, if you notice that something you've created does not work properly, you should explicitly create a separate unit test for that scenario so people know what should be expected. It might feel like once you fix the bug, why does anyone need to know? Well, what happens if you change that model again? What happens if I have a dog, my dog barks, then my dog whimpers, and I want to add, for each of these speak methods, I want to add, I don't know, some kind of string to some other value. If I notice there's a bug there with maybe some inherited behavior or protocol, and then I try to add another, what's another noise that a dog makes? Thank you. If I try to add growl, and there was a bug with the first two sound methods, if I have a test saying any sound method might encounter this bug, let's test for it, then when I create a growl, I'll know I need to do that. So fixing bugs is great, but if you're just going to repeat them in the future, what the hell is the point? Right. That is a great question. So if we are doing kind of strict TDD, you would try to anticipate what that bug is, which is like a big leap of inductive reasoning. No, I don't know. Big leap in your thinking. Like you need to be able to say, this thing is broken in this way, and you should work backwards from the assertion, actually. Like that's really strict TDD, is thinking that this is how I'm gonna make a comparison, then setting up the building blocks to actually test it. And then you gotta verify your assumption, but usually that's based on some errors rather than like fixing the code and seeing if it works. So when we say test our models, we've got decoding, we've got bugs, and there's one other one that, like I said, we don't do very often because we actually don't add many functions to our models. Our models are very static. What are some ideas you have? If we are testing our units, our bits of work, and testing that this thing decodes and creates an actual instance of what I'm looking for or a set of instances, I am fixing bugs and making sure that they have tests that reflect what the issue might be. What else might we want to test? Yes. What? It's open-ended, but I have something in mind. Yeah. So a unit test tests our individual unit of work. It tests the code that we create that needs no other context really to work. So we decode models. We fix bugs in those models. What else might a model do? And the reason I hint that those things are usually static is we usually just have structs that have constant properties. But what else might a struct actually have? Might have methods. Yep. And so the rule, the last rule of a good set of unit tests is if we have any mutating or returning functions, so any methods that in our struct are literally marked mutating and change that instance, or return some other information, we should assert what we expect. So any mutating or returning methods, returning methods. That is actually the whole set of unit tests that you should ever have to do for your apps. Pretty much everything else is one of these other categories, whether it's an integration test, a UI test, QA testing, or a behavior test. Test that our models can be created, test that they can do the stuff we say they're going to do, and make sure we have tests for any bugs we encounter. Phoenix. No. You should be testing anything that changes your model or returns some value from an instance of your model. Which if you think about it, we've almost always only had one, which is decode. Um, Not necessarily. A post call is probably an integration test. Um, in terms of testing Firebase, I would say that's also an integration test. If you think about decoding, it's the opposite of encoding, and we can usually expect that to work. But also, decoding is not making a GET request. We've said it's simulating a GET request, but it's actually just testing that a model can be created from JSON. Liana? Oh no, hang on, sorry. Is this still recording? Yes. Would I also be testing my view models? No, because a view model is really what's informing the UI. Like a view model operates like a controller. It's set up differently in terms of the architecture, but it exists solely to get information into a view. Cool. So let me pull up something you might be familiar with. Has anyone ever made an app where you either look at the Ticketmaster API or you look at the API for the Rijksmuseum in Amsterdam, come of the Netherlands? Okay. When have you run into these things? It's okay, you can tell me. Yeah, the CTA. So from our CTA, we had to decode two objects, one of which I don't know where this glare is coming from. Ah, beautiful. Look at that. Thank you, Eric. Look at that. Amazing. So, oh no, I clicked open music. Sorry about that. Okay. So in the CTA, we had a model called, where are you at? Event, which is information that we got out of the Ticketmaster API. And we had a model called a, whatever you want to call it, a painting, a museum item, something like this. We had to decode a whole bunch of nested information. That's great. Then if we wanted to be marked proficient, just saying if, we might have added some unit tests for decoding those things. Unit tests to make sure our model worked. So to cheat, here I've got some unit tests. If I decode my events, then it should go look in a local JSON file. And this is the JSON that I based the structure of my model on, right? I got a response, maybe I looked in Postman, or maybe I just looked on the internet. I got a group of models. I figured out, based on this group of models, how I should actually set up the struct that will hold this information, this codable struct. And then I wrote a test saying, okay, if I decode this JSON, which I said arbitrarily is going to have 20 items in it, then I should assert, after fetching all that stuff, then getting actual events out of it, I should be able to assert that I've received 20 of these things. At every step before, if anything went wrong, so whether I couldn't find the JSON, or I couldn't get data from that JSON, or I couldn't decode that stuff into event objects, then I said my test fails. I just stopped it right there. So we've explicitly said at various points where, you know, if I had my way in an app, I would just put up fatal errors because that's a really good user experience. At those points, I've just said this test should fail because that's what we want to do, is just say, how does this thing not pass? This code might look very familiar to one person in the room. Cool. So we did the same thing for our museum items. We said, hey, I'm trying to decode you. Sorry, hey, I'm trying to get the JSON. Hey, I'm trying to get data out of that JSON. Hey, I'm trying to decode that data. And only then, if it works, I got 20 items out of there, do I say it's true? So what other things could we test besides just decoding our models? What did we just talk about? Let's go with a bug that we've encountered. Go ahead. Nah, let's make a method. So let's say for any event, I should be able to return some other object. And let's be a little sloppy here and just make a struct in here that says, hey, an event should be able to return to me a URL, not a string, but given its URL property, a URL that will, luckily, do me the favor of, what's this? Sorry, okay. That will be able to just look at an instance of an event, say event.getURL, and then it'll provide to me a URL object. So if I've got this method that's returning something, I should write a test for it. So if we're going to do this with strict TDD, What should I do right now? Yeah, let's write the test. Let's not change the model until we've written a failing test. What's the format for how I should create a test function? How should I name my function? Yeah, all that's required is that the name of the function starts with the word test, lowercase. So test get URL from event instance. Neat. So here's something cool we could do. I've got multiple tests here that deal with events. If they're going to be using the same setup code, I could just move all this into the function that's actually called setup. And then I could have a variable that I assign these values to. So var event JSON data is of type, let's just set it equal to an empty data. Then let's get rid of this. And now before each test, it's going to set up this data that we're using here. I'm going to leave this act step in here because even though it's going to be the same for both of them, all we are testing in this test is that we can get event info out of here. So if we put that all in the setup, we're kind of not really testing anything in this test. Do you want me to repeat that? So this was the arrange step. This was getting all the information from somewhere else. The act step in this decode events function, in this test to decode the events, what we're actually testing is that we can decode those events. We are testing this function on the Ticketmaster response struct. So there's a static function right here that we're testing. And because that's what we are actually testing in this function, even though it's going to be the same thing for this next test that we're going to set up, we're not going to move it out of here to the setup because it's literally what we're testing with this function right here. This test decode events is testing that we can decode events. So therefore, it should have the actual code that we are testing within it. Sunny.
So would you put all of the arrange component of every test in the setup?
Yeah. And so that's where it's going to start to get messy, and that's why we're actually going to look at quick in a little bit. But the setup function here, unless we created separate classes for each set of unit tests, which is actually an okay practice, it's going to call setup before each test, and that means that we might be setting up duplicative information. There's a way that we can rearrange this stuff that's much more intuitive and is based on, again, on like how other languages test. But right now, yes, it's going to do this whole, let's go get a JSON file for each test. And that JSON file was event JSON. So we're still going to get that even when we run this decode museum items JSON. Cool. All right. Let's act. Let's go get, for example, any event. So I'm going to decode the JSON. And then I'm going to guard. I need events. Yep. Sorry. I'm going to add another step here saying, hey, let's guard that events.count is greater than 0, else what should we do if we couldn't get any events here? Yeah, let's just fail it. Let's fail it saying no events were found. And then we will just say one last step. Now we know events, be quiet. Cool. We know events has more than one thing, and now all we're going to want to do is we're going to want to assert that if we looked at the first item, so if the count is greater than 0, then we at least have a first item. And then we're going to say for this item, get URL from get. Let's look again at our model and say, what's that URL actually going to get for us? That URL is what, Sunny? What does URL provide us with? A URL for this actual piece of art or a URL for an image? Okay, so this would be, if we hit the API, we'd get back this specific item.
Yes.
Cool. So get URL for item. Oh, item. What's that? For event. Thank you. And then here's what I want to know. I want to know that the type of this thing is a URL. Has anyone ever figured out the type of something in Swift? Yep, there is a function called type, or hold on. Let's do this out here. There's a function called isType. So events 0 get URL for event. We want this to be a URL. How do we see that it is of that type? Should we go talk to my friend on the internet? Let's do it. Swift, see if instance is of type. And check this out. Here's a fun little aside. We've got this function called type of, a value for which to find the dynamic type of an instance. So there's just this function called type. You give it a value and it returns to you the type. Here's the important distinction about this function. What is the only one line, what is that one line of definition they give you? Returns a dynamic type of a value. This is super important. The dynamic type of a value is what it actually is at runtime. So the dynamic type is when it runs that code and it looks at that instance, what it is at runtime. This is different than probably what? What's that? Holding down option. Yes, exactly. What is holding down option doing? When is it checking for the type of it? Yeah. So even though our compiler tries to predict what the actual types of everything is, bless you, if we're using dictionaries, if we are using an any, if we are using any object, if we're using protocols and all this stuff, the dynamic type might be different than what you see in the code you've written when you, to quote Sam, hold down option. The compile time type of something might be actually different than your dynamic type during runtime. And even simpler, what it's saying is type of is not a compiled function. Like it's not called when you compile stuff, but it's called when your code is interpreted. So it's not called until that function is actually used during runtime. What do you mean by those?
Wouldn't the type always stay the same?
What are the type? Yeah, it should always stay the same, but often it won't. And this function, think of this like, something that doesn't cooperate with the compiler. If we say go check the type of something, we're not going to return the value of that thing until it's run. So it's not going to return, we're not going to know the return type of calling type of until we actually run the code. So until we run our test, we're not going to get confirmation that this thing is a type of something.
Is that to account for operands that can hold type any, and then we'll get type only after runtime?
It's that type with the type of type T. Here, so T is a generic, and actually metatype is a generic, and type needs to evaluate what we should expect to see when we look at an instance of T. And I think that's kind of as far as we should go with this, if that's okay. But we can anyway, we can use this type of to, in our code, evaluate at any moment what the type of a specific object is. If you remember, if we did something like t.self, we would get back the type of it. This is a function that actually evaluates that for us. So if I want to get URL for event, let's call type of T. Yeah, let's do this in a little bit more of an expressive way. So let first event URL equal that. And now we want to assert. Let's make a different assertion. Let's assert equal. Let's assert that first event URL, and what type do we expect it to be? Yep. Let's assert that they're equal. Let me just make sure I didn't lose an argument here. Assert equal. All right, I want a message. So when does this message come up? Yep. So first event did not provide a URL for its get URL for event method. So if it fails, that's what we know. That's all we know. We're testing a unit of our work. Amazing. No, so this is asserting equal is looking to compare the first and the second argument. The first argument should literally equal URL. So the type of it should be URL. We'll find out. So if I run this test right now, what's going to happen? Yeah. It's not even going to compile. Huh. Oh, that makes sense. We never created it. But first we have our test for what we actually want to be true. So let's go change our event model. Let me just copy this name first. Cool. Now let's create a function. Mark instance methods. So func get URL for event. What should it return? Yep. And then let's take URL dot. How can we turn a URL into a URL? Not like that. What should we do? Yeah, let's initialize a URL using that string. Which one of these do we use? These are looking at the local file or directory at a path. These are coming from a decoder. These are coming from file system. Amazing. Have you guys ever used this thing that you've probably copied and pasted a million times, your network helper? Which one of these, if you were to look at it right now, yeah, creates a URL using this specific method? Let's see what it says. Oh man, has to be unwrapped. All right, let's return a URL. Yeah, all right, let's make this optional, which means that we can fail here at this step if we can't turn the string that is our URL into an actual URL object. Now that we've noticed that, let's go change our test to make it even more exhaustive. Let's let this guy now be an optional. Did I type the right thing? Yeah, kinda. Maybe. We'll find out. Then first event URL. How can we make this fail if we don't get back the right kind of object? What kind of statement should we have here? We're going to XCT fail for something specific. So if this returns an optional URL, yep, let's guard that it's not nil. So guard let event URL equal event URL, else let's XCT fail. XCT fail with a message. What would be an appropriate message here, Jason? Not retrieve URL from the event. Cool. Let's look at our messages. All right. Let's make you a var. Cool. Let's change you up. Guard let event URL. That. Okay. And now, what do we have to do in order to actually make this assert equal work? Well, we gotta actually not test that at all, right? We have an instance of a URL, but we're not testing that this is an instance of a URL. We're testing its type. So this is where we actually have to do the type thing. So let event URL type equal type of event URL. And then at this step, if all the magic works, and who can say, event URL type should be a URL. How do we feel about all this? We needed to get an event, so we had to fail this test. If we couldn't get any events, we had to try and look for a URL in the first event, since we know there's at least one event, and then we had to actually get the type of that thing. Now we've still got an error. Interesting. URL.type needs to conform to equatable. Damn. How are we going to handle that? Well, check this out. URL is equatable, but URL.type is not equatable. That stinks. What if we change our test? What if we just say, for this test, that the first event should be able to create a URL?
So would you end up making the URL type here?
Mm-hmm.
And then pass it to the XCT exert equal
Yep. So what we might do is pull this crap out. We might instead do this. Get rid of you. Get rid of you. Now we're going to create a URL out of the first event's URL property. So we can get rid of this. We can just say first event is the first event. Then we can say event URL is first event, but we're turning it into a URL. And then string first event dot URL. So guard, nope, it's private. How do I get it? Maybe I got to change my model.
But follow-up question is, a lot of this can be done as a computed property.
Mm-hmm.
And so are computed properties then something you want to test for, or does it make more sense to make them into functions?
Good question. You should probably keep them as a computed property unless they need some external information. So if this function was specifically to turn a URL from an HTTP request into an HTTPS request, then it should be a function. But if you have a computed property, it's just to take and transform in some way some private property based on like regular stuff.
Can we keep that as a computer property? Create a function that does what a computer property is doing, test the function, make sure we actually return the accurate data, and then get rid of the function.
No, you're testing things that you want to use it for. Like you could test that this is just a computed property. This could be a computed property called URL and be fine. But you're not testing for things that won't end up in your code. Yeah. So to be lazy, make that a let statement. Unless we wanted to extend type, so event.type, to make it equatable, we're probably gonna have to do it like this. I know this is fun. I love it. So we're gonna guard that we can create a URL, and then there's another XCT assert that we can do. Ready for it? Let's look at it. Interesting. Interesting. Got XCT fail, but there should be something else. Has anyone ever passed a function by default? Passed a function by default. Logically, if all these things don't fail, we know we passed. No. Well, here's one way we can do it. If we know that we don't want nil, we can make a comparison, say XCT assert true, that this is not equal to nil. Ooh, amazing. Where'd you find that? What do you think this does, Michelle? Yeah. So there's gonna be an Xcode test for most cases that you want to end up with. Let's get rid of these guys. Let's make you a let constant. but just like the first time we did it, more so than what you're actually testing for is the process. So you want to set up your assertions first, and then based on what you can do, you can refine them, but you want to assert something first. That's the process of testing. That is the most important thing for TDD. Very warm. We're working backwards. Yeah, but the thing is then you are working based on a lot of assumptions. You are working based on the assumption that your code works in every way if you've created it. Here, we're only creating units for those things that we think need to exist. And that's why for TDD, you would test first and you would say, excuse me, you would say, I'm going to create this thing that I'm going to use in this way, as opposed to, I've created some stuff. Let me think of hypothetically how it works and how it might not work. All right, so we have added a test to get a URL from here. Let's take a 5-minute break, look at Quick, and then there's a closures quiz, got an action-packed morning. But Quick is really nice just to give a little preview. It's a framework. How can we get that framework? Yeah, CocoaPod. Pod. And it's got this nice descriptive syntax where it says, here's my unit I'm going to test. It's going to describe a dolphin. Okay, it's going to have some setup before each step. You can also do a setup within certain tests. So for a dolphin, before each test, I should set up the ocean and add the dolphin to it. And then the functionality I want to test here is a click. Dolphins make clicks, that's a noise, I guess it's some behavior they're testing. And they're testing one specific way that a click might work. So it looks like if they were creating this dolphin using TDD, the click function should return a string that is click with a bang. So it's literally what they're testing. They say their unit, they do some setup, they test some behavior, and then this is where Quick kind of beats XCT test. If you remember, we had to add our setup code that we'd share across in one specific spot. You can do your setup code at any point before any test using this before each block. And the other benefit is just this descriptive language is it should emit a series of clicks, and I expect the series of clicks to equal click, click, click. When I say this is used in other places, it's used in Ruby, this is a Ruby gem that does the same thing. This is an Objective-C testing framework that has a similar syntax and a similar format. And this is a Go testing framework that does something similar. Kevin, if I had to ask you what this BDD is, where'd he go? Oh, he's gone. Cool. Let's just leave that one lingering. What do you think behavior, nah, damn it. Behavior-driven development. If you're going to have models that do a lot of things, like in a game, you'll use behavior-driven development. These frameworks are very much set up in a style that is geared towards behavior-driven development. This looks like you could set up a game board. Let's take a quick straw poll. Do we actually want to convert our Xcode test into Quick, or do we want to move on to the closures quiz? So everyone close your eyes. Guys, it's democracy. Close your eyes. This isn't a caucus, it's a vote. So close your eyes. Do we want to convert these tests into Quick? Raise your hands. Okay, do we want to move on to the closures quiz? Cool, it's equal. Olympia, what do you want to do? Would you like to convert our Xcode tests into quick, or would you like to move on to the closures quiz? Okay, sounds good. Let's take a 5-minute break. We'll do that for a few minutes and then we will move on.